This is Dr. Mohan Lakshmi, Professor and Head Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology, Kanyakumari District. So, in this lecture, we'll see what is fog, edge, and cloud computing in IoT. So, on completion, the students will be able to define what is fog, its characteristics. They could be able to distinguish the fog, edge, and cloud computing. They will be also able to list the key features of the fog and edge computing. So fog connects the cloud to the edge. So you could see here the cloud is connected to the edge. That is through the fog. So which is depicted in the presentation. So this is of course with a managed infrastructure. So here at the edge you could see a substation IED, substation computer, that is IoT thing. Whereas in the fog you could see a router, then a fog router, CPU coprocessor, that is a processor which works in aligned with the main processor. Fog definition. What is fog? So fog computing seamlessly extends cloud computing into edge for secured control and management of domain specific hardware, software and standard. It could compute, store and network functions within the particular domain. It enables secure rich data processing applications across the domain. So fog computing, it is a platform which provides a low latency virtualized services and it is linked to the cloud computing infrastructure. Edge devices request compute, storage and communication services from the fog. The fog provides local low latency response to these requests and forwards relevant data for computationally intensive processing. So these are certain fog computing characteristics: low latency, that is the video delivery, navigation information, location awareness, something like traffic lights, navigation, sensor networks, then widespread geographical distribution, then mobility, that is fitness trackers, phones and vehicles. So from this figure you could see from the cloud to the fog, then to the edge. So the cloud computing, it involves SaaS, big data analytics, scalability, resource pooling, elastic compute, secure access, IaaS and PaaS. In the IoT enabling technologies we have seen already. And here coming to the fog computing, there will be a dim analytics, real-time control, then data ownership, secure multi-cloud networking. And coming to the edge computing, you could see the dedicated app hosting or embedded OS, device management, data service communication. So these are the key features for the fog and the edge. So when it comes to the app hosting, so the fog we have quite vast one, whereas in the edge it is limited. And coming to the data services, fog as well as the edge, it is yes. And data and application management, in both the cases it is yes. And coming to the security aspect, it is data protection sessions and hardware level, whereas here it is with a VPN or firewall. And coming to the resource pooling, in the fog it is possible, whereas in the edge it is not possible. Similarly, coming to the modular hardware, in the fog it is possible, whereas in the edge it is not possible. Virtualization with the Windows support, it is possible with the fog. And real-time control and high availability, it is possible with the fog than the edge. So edge computing, these are the basic differences between the edge computing and the fog computing. So awareness of devices and few services, unaware of the entire domain, whereas in the fog computing it is device independent, intelligent and aware of entire fog domain. So there is a limited control in the edge domain, whereas here it could control all the devices in the domain. So in the edge computing the cloud is unaware, whereas the fog computing, it extends the cloud to the fog level And here we have edge computing, we have a very limited network scope, whereas here in the fog we have a complete network scope. And there is no IoT vertical awareness in the case of edge computing, whereas in the fog computing it supports and enable multiple IoT verticals. In the edge computing, once again, usage of edge controllers or focused on the edge device command and control, whereas here in the fog, the nodes that are very versatile and capable of performing a variety of functions like application hosting and management. Here in the edge computing, again the security scope is very limited, whereas here you have end-to-end security. So you could have seen end-to-end encryption in the WhatsApp and all, so something similar to that. And edge computing analytics scoped to a single device, whereas here it enables collection, processing and analytics of data from multiple devices in the edge for analysis, machine learning and detections, anomaly detections and systems. So here you can see cloud and edge computing, which is our complementary technologies over IoT. So you could see in the upper part, which is a cloud, whereas in the edge you could see the different networks connected. At the lower level you could see the sensors and controllers connected. And cloud computing, in cloud computing the collected data is streamed to a central server, and the data is processed on a powerful central server which is usually far away from the data source. So cloud computing, or simply we call it as a cloud, which means to host and deliver on demand computing resources, or which could service or serve via public infrastructure. Something that is a very good example is internet. The services vary from elementary services like computation and data storage to more advanced services like machine learning. Cloud computing provides highly scalable and almost unlimited storage for business solutions. It provides really high processing power when compared to the fog or edge computing. High latency, possible downtime, and security could be the challenges or issues in cloud computing for IoT. So edge computing, it brings processing power closer to where the data is being generated. That is very close to the device. That's why it is called as the edge. It does not send the generated data to a central location directly. So the data can be processed on the device where the sensors are connected or a gateway device in close proximity. Fog or edge computing and storage systems are located closer to the edge to eliminate latency. This is the main difference between the cloud computing and the edge computing, where the latency will be more in the cloud, whereas it gets reduced in the fog or edge. So this can be integrated with the cloud computing whenever needed. So this could act or work as an extension of cloud computing. So the main goal here is to reduce the amount of sent data, to reduce latency between the nodes, to improve the overall system response time. So as in the cloud, it is not sent to a central location. It is considered more secure. Edge computing is used to process time sensitive data, while cloud computing is used to process that is not time driven. So autonomous vehicles like self-driving cars need instant decision to avoid collision or detecting pedestrians. So the sensor or camera data needs to be analyzed on the vehicle, that is on the edge. So whenever we talk about the edge, it is nothing but very nearer to the device to eliminate the latency. Even though there are well-known cloud computing advantages as hardware independency, cyber security, scalability, harmonization, low maintenance, high implementation times with less risk. However, this also has drawbacks. Some disadvantages go against the industrial sector's fundamental requirements, something like availability, response time, or privacy. So you could see a self-driving car where it has a mobile wireless gateways. You could see this is one example, and this chart totally explains the comparison of the concepts related to the cloud, fog, and edge computing. So the what are the features, that is access, availability, bandwidth, capacity in case of computing as well as storage, connectivity, how the content is distributed, content generated, where it is generated, control, data analysis, data processing, latency, location of resources, whether it is at the center or at the edge, scalability, how far it could be multiplied. So, whether it's high or low, security aspect. So, security, coming to the security, fog and edge computing is stronger. And coming to the mobility, even the mobility, the fog and edge computing is highly supported, and the number of users and how the virtual infrastructure location is made, that is whether it is an enterprise server or it is user devices or enterprise. So here you could see one picture where this is actually building automation, related to the building automation. You can see three different domains over here. One is sensing domain, the other one is, then second one is network domain, and obviously the last one is application domain. So in the sensing domain, you could see various sensors or the various controls available here, something like energy meter, smoke sensor, light sensor, temperature or humidity sensor. And coming to the IoT, you could see the various tags, cameras, which is connected to the Wi-Fi or RFID, the router, the Zigbee is involved, and the gateway is IoT gateway is there. And finally, coming to the application domain, you could control and monitor. So a full grid contains the generation, transmission, the distribution, where we emphasize the electricity distribution network with a coupled information network on top. So this part of the grid contains the infrastructure for distributing electricity to customers from the transmission grid out to the substations, and finally consumers with smart meters to measure quality of the delivered electricity as well as to handle the billing aspect. So here the smart meters can be seen as a type of IoT devices which communicate with Zigbee, LoRa, NB-IoT. LoRa is long range. Altogether, they build up the advanced metering infrastructure, AMI, which is the heart of a smart grid system, which we have seen in the previous figure. So smart meters, so it is instant usage data from the smart meters are collected by the sensors, and then it is sent to the utility head ends via data concentrators for further analysis and storage, which can be used for billing or statistics. A data concentrator, so which is nothing but hundreds and thousands smart meters are collected at the data concentrators, and it is related to the AMI head end. AMI head end will have a broad spectrum of the data that is stored, and it is processed at the AMI head end, such as the consumer short long-term electricity usage data. So electricity usage data of the customers follow the path 1, 2, 3, that is upstream, whereas the commands from the control follow the reverse path, which is downstream, 3, 2, 1. Some data generated at the smart meter is used for billing. As such, it needs to be correct, it can be aggregated and only available to the AMI head end at regular intervals and not in real time. Other data generated at the smart meter offers the possibility to improve the overall electricity quality if it could be shared instantaneous with at least the data concentrator or the substation for the electricity flow. So these could be the some of the possible assessment questions. So what is edge computing? What is the role of cloud computing in the IoT? We could what could be the comparison related to the concepts of fog, edge, and cloud computing.